Problem number 7. The bird is flying in a straight line, initially at 10 meters per second. It uniformly increases its speed to 15 meters per second, while covering a distance of 25 meters. What is the magnitude of the acceleration of the bird? On the left we have 5 different choices, so we need to solve this problem and pick a good one. Solution. What is known here is that this motion is with a constant acceleration. And also we know what is initial speed, what is final speed, and what is distance. It means that we can use formula number 4 in kinematics, which is not including time. And this formula looks like this. Final speed square equal initial speed square plus 2AD, 2 accelerations multiplied by distance. From this formula we can immediately find what is acceleration. Here we have a formula for acceleration, and we have, after we put numbers, we have acceleration equal 2.5 meters per second square. Problems number 8 and 9. The following information is used for questions 8 and 9. A flat disk rotates about an axis perpendicular to the plane of the disk and through the center of the disk with an angular velocity as shown in the graph below. Question 8. Determine the angular acceleration alpha of the disk when time t equal 2 seconds. Solution. We have a graph, angular velocity versus time. And from this graph we can find what is instantaneous acceleration just using slope for this graph. But here we have a straight line. It means that angular acceleration everywhere is the same. So we can just count what is the slope of this line. We can take, let's say, angular velocity for time 2 seconds and for time 0 seconds. And we can use formula change of angular velocity over change of time, that's angular acceleration. And in our case it's equal 0 minus 4 over 2, which is negative 2 radians per second square, which is answer D. Question number 9. Through what net angle does the disk turn during the 3 seconds? So here we can use another equation. We can use average angular velocity for motion with a constant angular acceleration. In that case we can use formula this one, average velocity plus final velocity over 2, that's average velocity multiplied by time. We can choose time from 0 to 3 seconds. This is in our question, and put this angular velocities. Initial it's 4 and final is negative 2. So that will be solution. Negative 2 plus 4 over 2 multiplied by 3. That will be 3 radians. Correct.